In this video, we'll be looking at problems on page 940, 1 through 7, and 9 through 13. These problems involve solving 1 and 2-step equations. Alright, I'm not going to do the problems on the assignment. I'm going to do ones that are very similar. So I'm going to begin with one like number 2. Like number 2. Alright, number 2 says 8 equals m minus 13. A similar problem would be 10 equals x minus 7. Alright, we want to solve for x. That is, we want to get x by itself. We're looking for the value that makes this statement true. Well, currently we have x and then we're subtracting 7. Well, we want to undo the subtract 7. The inverse of subtraction is addition, so I add 7 to both sides. To both sides. The negative 7 and the positive 7 cancel each other out. They add to 0, leaving only x on the right hand side of the equation. 10 plus 7 is 17. We have x equals 17. Now we're going to verify that solution. I'm going to take this value of x being 17 and I'm going to substitute it back into my original equation. I'm going to come over here to the right and show that. We still have 10. We still have equals. But x becomes 17. Substitution. Minus 7. The only difference between the statement in blue and the statement in green, we have substituted 17 in place of x. What is 17 minus 7? Well, that's 10. So that leaves us with the statement 10 equals 10. This statement is true. Since this statement is true, we know that x equals 17 is a solution. This is a value of x that makes the original statement true. Alright, now I will do one like number 5. Like number 5. Okay, number 5 says 7h equals 63. A similar problem would be 9m is 45. Well, 9 is connected to the m. We call this number the coefficient and the letter is called the variable. The coefficient is connected to the variable. We know connected means multiplied. So we want to undo this multiplication. The inverse of multiply is divide. I will divide by 9 on both the left and the right. Well, 9 divides 9 to leave 1 m. We simply write m. When we write m by itself, the implied coefficient is 1. It's like these two canceled each other out. Equals 45 divided by 9 is 5. We think that m is 5. Again, we will perform the substitution. 9. But instead of m, we'll substitute 5. Equals 45. The only change from the initial blue statement and the green statement is we have substituted 5 in place of m. What's 9 times 5? It's 45. So we have the statement 45 equals 45. That is true. Therefore, we know that m equals 5 is a solution. Alright. Next, I will do number 10, a problem like number 10. Okay, number 10 says 6m minus 4 is 14. A problem similar to that would be 4m minus 3 equal 29. Alright, our goal is to get the m by itself. Currently 4 is being multiplied by m and 3 is being subtracted. So to undo that, we do in the opposite direction. First, we'll undo the subtraction. The inverse of subtract is add. whatever we do to one side of the equal sign, we do to the other. Negative 3 and positive 3 add to 0, leaving only 4m on the left. Equal stays in the middle. 29 plus 3 is 32. You notice each time we show what we're going to do and then we show the new line. And each time, whatever we do to one side of the equation, we do to the other. So now we have 4m equal 32. This is 4 times m. The inverse of multiply is divide, so I will divide by this 4 on the left and the right. 4 divided by 4 to leave m. 32 divided by 4, well, that's 8. We believe m to be 8. Now we're going to take this value of m being 8 and substitute it back into our original equation. 4. Instead of m, we believe it's 8 minus 3 equal 29. The only difference between this statement and this statement is we've substituted 8 in place of m. 4 times 8 is 32 minus 3. I didn't do anything to the right side. I simply evaluated 4 times 8. Now, 32 minus 3, well, that's 29. The left expression is 29. The right expression is 29. This statement, again, is true. Therefore, we know that m equals 8 is a solution. It's a value of the variable that makes the statement true. One more problem. Number 13. This will be like number 13. We have x divides 7 in that problem, so I'm going to make it x divided by 5. Plus 3, let's go with a plus 4. Equals negative 2. I'm going to make that a negative 7. Alright, again the goal is to get x by itself. Currently it's x divided by 5 plus 4. We undo the added or subtracted part first. I'm going to undo the add 4 by subtracting 4. Whatever I do to the left side, I do to the right side. Well, 4 subtracts the 4 to leave x over 5 on the left. X divided by 5. 4 subtracts 4. Equal remains the same. Negative 7 minus 4. You can consider this being negative 7 plus a negative 4. Remember, our keep, change, change. Negative 7 minus 4 is negative 11. Lastly, it's x divided by 5. Well, how do we undo division? We multiply. I will multiply by 5 on the left and the right. Connected means multiply. 5 times x is 5x. Divided by 5 leaves just the x. 5 divides by 5 to leave 1x. We simply write x. Negative 5 times 5 is a negative 55. We believe our solution is negative 55. We're going to substitute that back into the original. X over 5, where x is a negative 55. Negative 55 divided by 5 plus 4 equals negative 7. From this statement to this statement, we have substituted negative 55 for x. Negative 55 divided by 5 is negative 11. Plus 4 remains the same. Negative 11 plus 4 is indeed negative 7. So again, we have a true statement. Thus, x equal negative 55 is a solution. With the assistance of these problems, you should be able to successfully complete page 940, 1 through 7, and 9 through 13.